I literally looked at my clock. I was like, it's 1 o'clock. I thought I was going to be completely in here alone. That would have been very awkward.
Check, check, check. All right, hello at home. Can y'all hear me and see me and see the screen?
Yes, sir.
Yes, everything's good? Okay.
Yes.
All right. Let me just kill one light here. All right, so today is actually a really important day. We're going to be talking about polynomial functions. We started the conversation last time. Let me just turn this camera just a little bit. I feel like I'm forgetting something. I think I'm okay. All right, so we're going to be talking about polynomial functions. From last class, we started the discussion and we talked about some of the properties, right? That they're all smooth and continuous. If n is greater than 2, then they're curved. And I told you about this leading coefficient test, which basically tells us the shape of the graph. You know what? I'm going to turn my camera. For those of you at home, you can see my screen. There we go. All right, so basically tells us what we call the left and right end behavior of the function is. So our ultimate goal today is that I provide you a polynomial function, and then we figure out how to graph it, right, by hand. So before we do it, I'm going to show you a program here that I have where I've already kind of graphed it. Let me find you. Where are you? There we go. Okay, so this is a program that I use to graph things, and make this a little bit bigger. So what I want you to pay attention to on this is the very bottom down here. This is the actual polynomial. So this is what we're looking at here is the polynomial x cubed minus 4x squared. All right, so let's talk about some of the characteristics of this polynomial. First, it is smooth, right? It is curved, and we should expect it to be curved because the highest power of x that we see down here is 3, right? And because that's 3, greater than or equal to 2, we should expect curves. And the right end of this goes up, the left end of it goes down. And then it has a couple of x intercepts, right? Has x intercept here, x intercept here. Right? So look at that first x intercept at 0. Do y'all notice that if you were to draw this graph, right, from left to right, what's happening is the graph is coming up and it's almost just kind of like touching that x-axis and then coming back down. You could say it's just touching or bouncing off the x-axis. You think of it both ways, right? Whereas at the other x-intercept, it actually crosses through, right, goes through the x-axis and continues up. That bouncing and crossing action is actually something we can predict. If we know just the right thing about the function, we can predict where it will cross and bounce. I will explain it all, but I'm just trying to get you to see it visually. So let me change the function, okay? I'm going to change this function slightly. What I'm going to do, do y'all notice above this what this is? Like this is the original function down here, x cubed minus 4x squared. Can y'all tell what that top version is? It's, yeah, all I've done is factored an x squared out. You see that? Also notice that if I factor that x squared out of these, if I set this factor equal to 0, I get 4, and then the other one you get 0, don't you? Right? And isn't that where our x-intercepts are? At 4 and at 0, right? Which we should expect, because anytime we've factored like a quadratic and set those factors equal to 0, that's where our x-intercepts were. We have the same thing happening with polynomials. Let me change one thing here. Come on. So how do I want to do this? I want to do fourth degree. Okay, so look at this one here. I'm going to have to zoom out a little bit. Ooh, too far. Can't read. There we go. So here's a graph of this new one, right? So it's x to the 4th minus 4x cubed, right? Again, it's smooth and curved. The left side of this goes up. The right side goes up. We still have two x-intercepts, don't we? Here and here. Now, I've also written this in the factored form. Aren't those the same two x-intercepts though? Right? Plug in 4, you get 0. And then plug in 0, you get 0. So this has the same x-intercepts as the previous problem, doesn't it? The only difference on this is an x cubed. I'll flip it back to what it was right before this. Before, when it was x minus 4 times x squared, this is what it looked like, right? It bounced off at 0 and crossed through at 4. But if I change that x squared to an x cubed, everything changes, right? It's like the whole graph changes. But the x-intercepts, what happens here at 0? Do I bounce off or cross through? I cross through, right? I cross through here. And then at this x-intercept, I cross through again, right? So let me give you another. I'm going to see if you can figure out what's going to determine whether or not we cross or cross through or bounce off. So I'm going to change it one more time. Let me make this. Okay, so I change it again, right? Do y'all see the difference? It changed. This looks really crazy, but if you factor out an x squared and then do some more factoring, here's what it factors to be. X minus 4 squared times x squared. Same x-intercepts, right? 4 and 0 again. I have 4 and I have 0 again. But at the 0 this time, I am bouncing, and at the 4, I'm bouncing, right? At both places. Have y'all figured it out? What's making it bounce or cross?
Is it because both have a power to an even number?
Even, okay, so Josiah is saying, is it because there's an even power on both of these factors? Like they're both even powers, so we're bouncing. Let me change it back. Let's go back to what we were looking at just a second ago. Here at this one, the power on the x minus 4 is odd, right? And this one is odd, and they cross through, right? Okay, let me go back to the one we looked at before that. This was x minus 4 is to the first power, right? So an odd power, and then the x squared is even. And look at 4, we cross through, right? Odd power cross through, even power bounce off. I wonder if that's what it is, right? Well, that's what it is, okay? Good that you caught that. So again, I'm going to formalize this, okay? I just wanted us to see it before we actually start writing down on paper what it is I'm talking about. You visually have connected it, all right? All right, so polynomials, I mean, you can just, I can play with this. I can start making this thing super crazy and add different x and y. Sorry, I can do all sorts of things, all right? So in general, it's kind of tough to graph polynomial functions because they all look so different. You know, parabolas are parabolas, up, down, that's it. You know, vertex, x-intercepts, you have them or you don't. Polynomials, much more complicated. So today, how do we sketch these? And I'm also going to mention it now. The homework assignment for this section, for the next two sections, which on our schedule, let me see. The sections we're looking at right now are 5.1 and 5.2 right here. Polynomial functions in their models right here. We are not going to do the homework assignment on Pearson MyLabs. If you've already done it, sorry. I'm going to give you a set of problems to do instead, and that'll be your homework assignment, right? So that's what we're doing, 5.1 and 5.2 right now. It's all about, can we sketch polynomial functions? So here we go. You ready? I'm going to give you the set of steps first. Once we have the steps, then we will go and try and do some examples. And as we do examples, we'll see how they start getting crazier and crazier. And then eventually we're going to have to submit, give up, because we'll get a problem where we can't factor it. And then we'll have to learn a new way to factor. All right. So here we go. How to sketch polynomials. Polynomial functions. So there's going to be a set of steps. Just like when we graphed parabolas, there was a set of steps, right? So for here, let me just turn this off. I apologize. Okay. So how to sketch, so just like with quadratics, we had a set of steps. Now we have a brand new set of steps to do polynomial functions. The first step is to determine the end behavior. Now, when I say the end behavior, I'm referring to what we talked about at the end of class last time, which is this leading coefficient test. I'll just copy it and bring it over. The leading coefficient test told us for a polynomial what happens with the shape of the graph at the ends, right? And all we need in order to do this is to know the degree of the polynomial, which is the highest power of x, and we need to know the number in front of it, whether or not it's positive or negative. If you know that, you will be able to tell me which, what the sides of the polynomial do, okay? That'll be the first step. The next step is to find any X intercepts. All right, this is the hard step right here, because we know from what we've learned about lines and what we've learned about parabolas and quadratic functions, and that is anytime you want to find the X intercepts of a function, you have to set the function equal to 0 and solve, which in the past hasn't been too bad because they've either been linear or they've been quadratic, in which case we kind of knew how to handle it. But if it's just a general polynomial, it becomes much more challenging to figure out the solutions. So, but the idea is simple. Take the function, set it equal to 0, solve. All right, once we do that, this step right here, when we do this, most likely we are going to wind up factoring. Okay, we're going to wind up factoring in this step, all right, when we actually set it equal. When you factor it, you imagine that you'll have something, these things right together once it's broken up into different factors. And what you're going to do is you're going to look at each of those factors and look at the powers on these. I'm just going to call this P1, P2, P3, and we might have more factors, right? Depends on how it factors out. We could have 4 factors, 5 factors, 6 factors, 7 factors. It just depends on the polynomial. We're going to look at all those powers, right? Now, when we factor something, the technique is that you take this factor, you set it equal to 0, right? So like whatever was in here, you take it, set it equal to 0. Then you take the other one in here, you set it equal to 0. Does this make sense to you what I'm doing here, the way I'm drawing this? Okay, you set this one equal to 0, and then you're going to get all these answers, right? You can get all these answers. And whatever these answers are, these are your x-intercepts, right? This is where your graph will actually touch the x-axis, right? You'll have points on the x-axis. So these will be numbers. This will be a number. This will be a number. This will be a number. Again, we may have more than 3. I'm just trying to give you a general idea. Those are your x-intercepts. Right? All those are your x-intercepts. Now, what we will do next after we find them is we will determine the multiplicities. So that's going to be our step 3. What's called the multiplicity? You determine the multiplicity. Might be a new word for you today. The multiplicity of each x-intercept. All multiplicity means, or all multiplicity is going to do for us is tell us whether or not we bounce or cross. Okay. And the way we do it is the pattern that was kind of recognized a moment ago. If the power, right? So when I say the power, what I'm referring to is the powers up here, right? If those powers, P1, P2, you have to look at each one individually. If P1, if the power is even, you will bounce off the x-axis. If you don't want to say that, you can say touch. If it's odd, you will cross through. And that's called determining the multiplicity of the x-intercepts. You have to do that for each one, okay? And so now you've got this idea of what's not only what the left and right are doing, you know where the graph hits the x-axis, and you also know whether or not you cross or you bounce off. And believe it or not, that's it. That's all we need. Sketch it. The steps for this are not as long and tedious as even the quadratic, right? The quadratic, you have to find the vertex, right? You use a formula, you do a quick sketch, then you figure out how many x-intercepts you have. You might have to use a quadratic formula, right? Then you go find the y-intercept, then you draw everything. Here, it's, if you can get the x-intercepts, if you can get this thing factored, you're in business. So let's go. Let's start with our first one. You all ready? See these 4 steps in action? All right, first one here. Sketch f of x equals, let's go with x to the 4th minus 5x to the 3rd. I'm just thinking here. Minus 14 x squared. All right, first things first. This is a polynomial function, right? You have to be able to look at that and know it's a polynomial. So are we all comfortable with that? It's definitely not quadratic, right? It's 4th power is the highest power we see. So the first thing I'm going to do, first step, is I'm going to determine the end behavior, right? So who wants to tell me what the degree of this is? What's the degree and the leading coefficient? Okay, the degree is 4, and the leading coefficient is the number in front of that x to the 4th power, right? So 4 is this power, and then the leading coefficient is the number in front of that, and that was a 1. So from there, you go to that little table, and you have to use the table to determine the left and right behavior. So looking off the table, our degree was even, wasn't it? And our leading coefficient was positive because it's 1. And so we're looking at this. So we know the left side goes up and the right side goes up. Is there, maybe y'all can help me because y'all are just learning this, or maybe you've seen this in the past. Is there an easy way to kind of remember that table? I'll tell you, I'll show you the way that I kind of think about it. Doesn't this top left one, doesn't that look like a parabola that opens up? So that kind of looks like x squared, right? This kind of does. And this is like even power positive leading coefficient. This is like x squared but flipped over, which would be negative x squared, wouldn't it? So that would be even power negative coefficient. I think that makes those two easy. Now these, you have to know what x cubed looks like, which is one of our like essential functions. And so you have to remember that x cubed goes down on the left and up on the right. If you remember that, then you can just think, oh, this is x cubed, odd power, positive leading coefficient. And then this is just that flipped over, so just make it negative. If that helps, good. If not, you know, you just have to remember the table. So going back to this problem, when I look at this and I say, oh, okay, I have an even power, right? I have an even degree. I know it's going to look like a parabola, and the leading coefficient is positive, so it's going to be going up on both sides. So up and up. So I'm just going to kind of do this. I know that the left side goes up. I know the right side goes up. In the middle, I don't really know yet, right? Second step. X intercepts. Set the function to 0. So I'm going to take x squared minus 5x cubed minus 14x squared and set that equal to nothing, right? And fortunately for us, this does factor, right? What's the, go ahead. Yeah, sure. Step 1 question.
So for the indicator, we only check the first
Highest power. It doesn't necessarily have to be the first term. It's you look across the whole polynomial, look for the highest power of x, which is 4. And then the leading coefficient would be the number in front of that one. Yes. Is that what you're asking?
Yeah.
Yep.
I was just curious if you would have to like do it for each other.
Yeah, no, there's only one degree, and that is the highest power of x. Okay, so that degree comes from that. And the leading coefficient is always the number in front of that highest power. Everything else is irrelevant. Here, look, here's a way to think about it, because we start to lose sight of why this leading coefficient tests work, why it works. But since you are all going to wind up in calculus, right, at some point in time, let's think about why this is true. Okay, I think this is a good little exercise. We're trying to figure out what's happening to this graph, right? So we know we have x to the 4th plus blah, blah, blah. And we know that the others are smaller powers. I don't know what the thing was, but these are all smaller than x to the 4th, right? X to the 4th is like the biggest power of x, right? So if I start going, imagine I start plugging in values of x out here, like 10. Well, 10 to the 4th power is going to be a huge number, right? 10 to the 4th power is pretty big. And then I'm going to add or subtract. I don't know. This stuff is going to be added or subtracted. All of this stuff together might actually be bigger or smaller than this number. It kind of depends, right? But if I go out far enough, right? If I just keep going out further and further, go out to 100, go out to 1,000, go out to 1,000,000, go out to 1,000,000,000. What happens is this term, this x to the 4th, dominates the other terms because it's the 4th power. These, even though it's cubed, and even though this next one may be squared, even if you put all these together, if your number is big enough, this one just completely overwhelms those. Does that make sense to you? It's like this one's ultimately in control of what happens as x gets huge. Now, when x is small, the other pieces matter, okay? They do have an impact. But when x gets huge, that thing, all this other stuff is just kind of background noise. This is the one that's really controlling everything. So the way we say that in calculus is this. We say, if you take, the way we will write this in calculus is like this. If you take x to the 4th, let me go back and look at that. Minus 5x cubed minus 14x squared. Well, the way we write this in calculus is like this. We say, all right, take that expression. We do this thing called the limit, and you'll learn this in calculus. It's not for here, but we write lim x. with an arrow going to infinity. So what this is saying is, look, you see this expression? If I let x get huge, that's what this means. This expression is going to become infinitely large. That corresponds to the right-hand side of the graph eventually going up, right? So as you move to the right, your graph eventually has to go take off. Understand? So that's why we only care about that one piece. It's the most important piece. What if I had put a negative in front of this, right? What if there was a negative in front of this? Well, it's still going to dominate all these others eventually, right? But because it's negative now, instead of going up, it's going to wind up going down, which is why it flips over. Okay, let's continue. Was that it? Are we good? All right. So do you all see how we can factor that? What is the first step you always do when factoring? What's the most basic factoring step? Take out the common factor. We call that the GCF, greatest common factor. You look at all the terms, you say, do they all have something in common? Here they do, right? What is it? X squared, right? Pull that out. And then what's left here on the inside? X squared minus 5x minus 14. Good. And now we have a quadratic in there, right? 3 terms, trinomial. We see if we can factor that. Again, that factors into what? X plus 2 minus 7. And now we've got it broken down to 3 separate pieces, right? We can set each of those equal to 0. So I set x squared to 0. I set x plus 2 to 0. I set x minus 7 equal to 0. And I'm going to get 3 solutions: 0, -2, and 7. These are my 3 X intercepts. I know that these are the only places on the graph where I have dots on the x-axis, right? That's the only places. That's step 2. Step 3 is the multiplicity. I'm just going to put mult, okay? Multiplicity. So you do these one at a time. Let's start with x is 0. What I do is I look to see if something is even or odd. What am I looking at to see if it's even or odd? Am I looking at the number here? No, you're not looking at the number. We're not asking,
You look
is
at the
this number
power.
even or odd? You're looking at the power of the factor that it came from, right? So where did this come from? This came from here, which came from that factor. And what is the power on that factor? Squared, right? X squared, which means what I should expect is that at this 0, I should do what? Bounce off, bounce off. Even powers bounce or touch, however you want to say it. Then I go to -2 and I say, where did this come from? It came from that factor. Okay, come up here to where you're factored. The power on that one is a 1, right? Because if we don't write a power, it's understood to be a 1. And that's an odd number, right? And since it's odd, that tells us that we will cross here. And then we go to 7, go back up to the factor. It's a 1 up there also. And so we should expect to cross here. Even you bounce, odd you cross, all right? And that's it. That's all we should need to sketch it. So here's how I like to sketch it. I just draw a real quick XY axis, the XY axis real quickly. The next thing I do is I put the X intercepts. So we know at 0, we have an X intercept. At -2, we have an X intercept. At 1, 2, 3, 4, 5, 6, 7, we have an X intercept. And I'm going to tell you right now, your picture does not have to be perfect, okay? It needs to be a rough sketch to give us a general flavor of what's happening. So from here, got it, my X intercepts. The next thing I do is I kind of very lightly in pencil, I put the left and right behavior. So back up here, both sides should go up, right? So again, very lightly in pencil, I'm just going to to the left of this red dot at -2, right to the left of it, I just kind of know that it's going to go up over here, right? That's not going to be part of my final picture. I'm just kind of thinking out loud here. And then on the right, I know that the right side must go up also, right? Now try to imagine now what this thing has to look like. As you move from left to right, you're going to be coming down from up here. When you get to -2, what are you going to do? You're going to cross through, which means you have to go past that point, but then you have to get back up to 0, right? You got to get back up to here. When you get to this point, what? Bounce
You're gonna
off,
bounce.
right? Bounce. Don't go past the x-axis, just bounce off, then come back down, and then go back up to 7, and then connect it and just go up, right? Okay, you ready? I'm going to draw a picture. I'm going to go down, cross through, bounce off, come over. Oh, I missed it. Try it again. Oh, okay, there we go. There's my picture. All right. Your picture might look different than this. Yours might look like this.
So there's no set amount of how much you have to go down and then back up.
Yeah, this down and like how far you go down, right? Or how wide these are. This is going to vary from student to student. All right. What we should all have is this. To the left of -2, we should all be above the x-axis. Between -2 and 0, we should all be below the x-axis. Between 0 and 7, we should all be below the x-axis. And to the right of 7, we should all be above. Right? Now, if you wanted to know how far down to go, right? Like if you wanted to know, like how, which of these is it? Or, is it further down? Like if that's something you wanted to actually get to be a more precise picture, which I think we would eventually, right? In Calculus 1, that's where you figure that out. Okay, you figure out how to figure out these lowest and highest points on these polynomials. It requires a whole bunch of stuff to build up to it, but we can do it. We can actually do it for parabolas, can't we? For a parabola, we can find that highest point and that lowest point. We have a formula for it. Do you remember where I told you the formula came from?
The vertex or
The
the
vertex formula. Do you remember where I told you it came from?
negative b over 2a?
Yeah, that negative b over 2a. Did I not say where that came from? I usually tell y'all. No? It's what? You can get it from the quadratic formula. It takes a lot of work to get it, but you can. It's actually very easy to show in calculus. In calculus 1, you can show that the vertex is negative b over 2a easily. So even when we were finding the vertex of a parabola, when we were doing that, using that negative b over 2a, that was kind of a gift from calculus. So when you get to calculus, finding these highest and lowest points will be easy. But when you walk into calculus, you have to be able to at least draw the graph first, right? You have to have this general shape first. Then you can start talking about those highest and lowest points. Because really, at the end of it all, what you're trying to do is, just think about how useful this might be. What if you had a company, right? And this is, time. Now let's say this is a profit, okay? The money you were bringing in, all right? And let's say time was broken down by months. So this was in January, February, right? March, April, May. And then you start looking at your profit for your company, and things are looking good, right? And then goes like this, and then comes back down, then drops again, something like that. So you own this company. This kind of looks like a polynomial, right? Smooth, curved, right? So what you might be interested here in is finding that point, right? And you'd say, what the hell happened here, man? Things were good, right? And we got to this point. Where is that point? Well, we can find that highest point. It takes calculus, but we can find it. And then you figure out, that's when we hired so-and-so and we need to get rid of them, right? Or something like that. right? This could be valuable. There's other examples that I could show you. I'm not going to get into them right now, but finding the highest and lowest points on a function is a major goal of calculus 1. It's called optimization, because at the end, what you're looking at is not just polynomials, but all functions. Like, as complicated as they could ever get, you want to be able to find peaks and valleys, because that corresponds to something in the real world potentially. So, all right. So here we are. We've got our picture. Everybody's got kind of a different picture, but we should all have crossing, bouncing, crossing. Left side's up, left and right side's up.
Professor, can I ask a quick
Absolutely.
question?
Mhm.
Can you show me where the bounce and the cross is again?
Yes. All right. So when we say bounce and cross, that's relative to the x-axis, right? Here's the x-axis. Let me get rid of some of these other pictures. Let me go back to my original one. When I was drawing here on the left side, let's say this yellow, do you see that when I come down, I actually cross through that green line? I go across it.
Yes.
But when I go down and back up, do you see I don't cross over? I just bounce off of it like a wall.
Yes.
And then I come down and then I go back up and I cross through again. So
Okay.
I crossed here, right? I crossed here, but here I bounced.
Okay. Yes, sir.
Make sense? Okay. All right, y'all ready to do another one? Let's do another one. I brought something just in case, so I could make up my own, because I didn't want to use the book's problems. I wanted to make up my own. So let's do, yeah. We'll make it look real ugly. F of x equals, let's go with x to the, let's go negative x to the 5th. My plus 2x to the 4th plus 15x cubed minus 36x squared. Sketch that, right? First step, I realize it's a polynomial, right? So the degree of this one is its highest power, 5. Okay, and then the leading coefficient here is -1. It's the -1 sitting in front of that highest power. So then you go and you hit odd powers look like x cubed, but then negative in front, so it flips it over. It should be left up, right down. The middle is a big question mark, which we need to figure out. The second step is the hard step. Take this thing, set it equal to 0. I will always start by seeing if there's a GCF. So is there something that these all have in common? X squared again, right? So I can pull out an x squared. If I do that, that'll leave here a negative x cubed, right? And I actually don't want to leave a negative x cubed. I'd prefer if it's a positive x cubed. I think it'll make it easier for us to factor. So is it all right if we pull a negative x squared out? Is that all right with everyone? You don't have to, but I think it will make your life easier. Negative x squared out. What we have left is x to the 3rd, now it's positive, negative 2x squared minus 15x, and then plus 36. So by pulling a negative out, it changes the signs of everything, right? And everything gets reduced. Two factors of X get pulled out, right? So y'all agree with this? Now, what you have left in the parentheses has more factoring that can possibly take place if you know how to factor it. What did we do in the last one? It was almost like quadratic, right? Or was quadratic. So we just went right through that step. But what about this? It's not quadratic. Anyone know how to attack that to try and factor what's in here? Go ahead. What do you got? Grouping. So there's a technique called grouping to factor when you have 4 terms. You can try to group. Grouping doesn't always work. Sometimes it does, sometimes it doesn't. I made this problem so it would. So let's see what we mean by grouping. So in case you've forgotten, I'll do it down here, okay? If we were to take just x cubed minus 2x squared minus 15x plus 36, the technique to group this is as follows, and it's taught different ways. Here's the way I teach it. I do the first 2 terms. Right after the first 2 terms, I draw a slash right through there. So basically what I'm doing is I'm cutting these 4 terms into two groups of 2. And then in the first group of 2, I pull a GCF out of just those 2. So they both have an x squared. So I pull out an x squared. And what's left here is x minus 2, right? If I pull x squared from both of these, I'll be left with that. Now I look at the second 2 terms and I try and pull a GCF out of this. But there's a little bit of a catch. When you do this next step, you need to have an x minus 2 in parentheses again in order for grouping to work. So do y'all see what I can pull out of both of these that would leave me with an x minus 2 here? Sometimes I actually write it down like that. I put x minus 2 here, and I see if I can't come up with what number would go here, that when I distribute it through here and here, I get back these 2. What number is it? Did I write it down wrong? Hold on. Shoot, I think I did. Hold on a second.
You won't be able to have a 2 because it's a 15.
You're right. Hold on though.
Probably an
The
8.
combination of my eyes going bad and yeah, it needs to be a 30.
Either needs to be a 30 or we need to have an 18x.
Yeah, you know what? Let's do this. I think my glasses must have fogged up or something right when I looked at this because I'm losing it. Let's do this. This is not going to factor with grouping. Do y'all see that? Okay. So I'm wondering right now whether or not I should change the problem or if I should now introduce you to the next thing, which is, well, maybe it does factor. Maybe this does factor, just grouping doesn't work, right? Grouping sometimes works, sometimes doesn't, right? So what do you feel like doing? Do you feel like you want me to introduce you to the new way to attack this, or do you want to do a problem where the grouping actually works first and then go do this problem? I don't care. Not all at one time, please raise your hand. Do y'all want to see how this works, or yeah? You sure? No one's really making me feel good about this. Okay, so let's just say right here, nothing works. Right? Nothing works. That does not mean it does not factor. Okay, that does not mean it does not factor. In fact, in your previous classes where you were learning to factor, they might have told you to just say that this is prime, but that doesn't necessarily, we weren't done. There's another way we can factor, all right? So, y'all ready for this? We're going to pause here. That's a pause button. Okay, we're going to pause. We're going to come back and we're going to finish this problem. But first, I'm going to take this problem. Start a new page here. And just for the sake, I just really want to make sure I have this down right. Yeah, okay. All right, so we are now going to talk about something called, I'm really curious if any of y'all have ever seen this. I'll put this over to the side. Synthetic division. Anybody here ever seen synthetic division before? Yes, a little bit. So here's the deal, all right? Here's the deal. There is a factor, okay? There is a factor. This does factor, okay? So I'm going to show you it in its factored form first, okay? Which is cheating. I'm going to show you that it does factor. And then after I show you it factors, I'm going to show you how we can get to that, okay? So the correct factorization of this is x plus 2, or sorry, x minus 3 squared times x plus 4. The question is, how in the hell do we get to that, right? From this. How do we get here from there, right? Okay, so here's how it's done. What you're going to do with this technique of synthetic division, first thing is you're going to look at your polynomial, you're going to look at the number in front and the number in the back. All right. You're going to take the number 36, write it down. And then below that, I'm going to write the number 1. And then you're going to start with the 36, and you're going to think about all the numbers that divide into 36 evenly, which means they divide in with no remainders. So does 1 go into 36 evenly? 36 divided by 1 is 36, so 1 would go in there. Would -1 go in? You could divide 36 by -1. So 1 and -1 go into 36. How about 2? Well, 36 is even, isn't it? So I'm going to do 2 goes in there and -2. Does 3 go into 36? 12 times, right? So positive and -3 goes in there. How about 4?
Yeah.
Doesn't 4 go into 36 9 times? So 4, positive and -4. How about 5? No, 5 doesn't. Does 6? Positive or -6 does. How about 7? 8? No. 9? Okay. 10? 11? 12? 12. Look, now I know you're sitting there going, holy crap, do I really have to do this? Like, yes, this is the method. It sucks, but it's all we got, okay? 12, and then what's next? 13 does not, 14, 15, 16, 17, 18 does?
Yeah.
Right, 2 times 18. And there's one last one, 36. Whoa, what did I just do? Did I do that? That was weird. I stepped on this cable and projector went off. That was strange. Doo-doo-doo. Whoa. It's weird. It's like everything vanished. Look at that. All the notes for today are gone. I better close this program and reopen it. That was really strange. I stepped on this and that happened. Do you think it'll happen if I step on it again? Or do you think that was just a weird coincidence? I have nothing to do with it. That's weird. Okay, so what we've done here is we have found what is called the list of all possible factors of 36. Okay, we make a list out of that. Then you have to do the same thing for 1. But luckily for us, all the factors of 1 are just 1 and -1. All right. Now, what are we going to do with this list? Now we have these 2 lists, right? We're going to create a new list out of these 2 lists. And what it is every single possible factor of 36 divided by every single possible factor of 1. So that means I'm going to do ±1 over ±1, ±2 over ±1, ±3 over ±1, which in this case, wouldn't that just be the original list up here for 36? Now, if this number was something other than 1, our life would suck, because then we would have to do all these numbers over that first factor, then all these numbers over that next factor. You'll see, I'll do another example. But for us, our final list will be the original list. Does anyone have questions on that? It's because you're taking all of the factors of 36, dividing them basically by ±1, which gives you back the original list. Okay. Yeah. I wish I had a better story for you as far as like a faster way, but this is the fast way. All right. Once you do this a few times, you start getting quick with it, right? So it does become a faster process. All right. Now the actual thing called synthetic division. So what we're going to do is we're going to take this polynomial and we're going to write down just the numbers, just the coefficients of these things, and we have to write them in order. So watch, I'm going to do it right here. The coefficients are 1, then -2, then -15, and then 36. So I'm going to write those down. 1, -2. I'm going to do a little bit different color here. I'm going to write down 1, -2, -15, and then 36. Okay. I'm going to put an upside down division box like this. And if you've never seen this before, like, don't freak out. Okay. I understand this is like really weird, but just bear with me. All right. You got it? Now, what to do here? What the hell does that mean? What is going on? Maybe I have a loose connection here. No? Just make sure all my cables are in right. Okay, so what we're going to do now is we're going to take the first number in this list, which there's actually 2 of them, right? 1 and -1. I'll start with +1. I'm going to put a +1 right here on the outside of this box. All right. Now watch the pattern of what I do next. I take this number 1 right here, and I bring it straight down, and I write it down right here, 1. Okay, so that first number just gets dropped down here. Now I'm going to take this number out here, 1, and multiply it times this. What's 1 times 1? 1. I'm going to put that answer underneath this 2, -2. Then I'm going to add those 2 straight down. When I add those 2 down, I get -1. You with me? -2 plus 1 is -1. Now do the same thing we did with that first number. Take the number out here, 1, multiply it times there, multiply it. 1 times -1 is -1. You put that answer underneath the -15. You add those down. What do you get when you add those down? -16. And then you do the same thing, 1 times -16, which is -16. And you put that underneath the 36, which gives you -16 there. and then add down. And when you add those down, what do you get? 20. Okay. This last number right here is what's called the remainder. And I'll explain more probably next class on what this actually means when I talk to you about long division, all right? What we are looking for here is that when we do this process, that this answer at the end here, this remainder, needs to be 0. Okay, it needs to be 0. Now, this is weird because I don't know if this is a problem with that or with this. Because this didn't, my computer screen didn't change at all. So it's making me think it's the projector. All right, so again, we want to do this, but we want to get an answer of 0 here. If this doesn't work and we don't get 0, we go check the next number. And we only have a few to check, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, but 2 on each one. There's 18 numbers to check. Sound like fun? Let's do the next one. What do y'all want to do? -1, or do you want to move to +2? I don't care. +2? Okay, let's go to +2. So I put a +2 out here. I've got 1, -2, -15, 36. I'm gonna work through this one slow still, but a little faster than last time. First step, take this 1, drop it, right? So you got a 1 here. 2 times 1 is 2. That goes here. Add these together, what do you get? 0. 2 times 0, 0. Add down, -15. Multiply 2 times -15, -30. Add down 6. Ah, it didn't work. And we go again. Okay, we go again. All right, so let's go to 3 because it's going to work. So when we go to 3, we get 1, -2, -15, 36. We go 3 out here, and now let's play our game. 1 comes down. 1 times 3 is 3. -2 plus 3 is 1. 3 times 1 is what? 3. Add down, what do you get? -12. Ah, 3 times -12, -36. Remainder 0. Okay, we're happy, right? We're happy. What does this do for us, right? Well, look back at, remember I told you let's cheat? I'll tell you what the answer is. Do you see that 3 is a solution, is an X intercept? What it turns out, what synthetic division allows you to do is find the X intercepts of a polynomial without actually having to do the factoring using like grouping or some other method. This is kind of a sneaky backdoor way of factoring, because now we know that X minus 3 is a factor, don't we? We know that since 3 works, we know that X minus 3 must be a factor. Let me say that again. If 3 is an X intercept, that means X minus 3 must be a factor. So here's how I'm going to use that information. You see this answer I got here? The remainder of 0? Watch what I'm about to do. This tells me that X minus 3 is a factor. Got it? And the coolest thing about this synthetic division is that these 3 numbers actually have meaning now. 1, 1, and -12. What they tell you is that the next thing you have is going to have these 3 coefficients. And the power on this one, this will be 1 in front of X to some power. That power will always be 1 less than where you started. So where did we start? X cubed, right? Right, X cubed. So this should be a 1 sitting in front of X squared plus another 1, but now the power comes down to X, and then minus, you no longer have X's because the powers are coming down, 12. Another way of writing that is x minus 3 times x squared plus x minus 12. We have essentially factored it now. Do you see? We have factored. We have taken this, what we're saying is this original thing is equal to this. Now, this is a quadratic, and we can factor that. Well, I hope we can factor that, right? Doesn't that factor? What does that factor to be? Minus 3 and plus 4. Right? And now we notice that we have two of the same factors, so we can put those together as x minus 3 squared, x plus 4. Now, look, I realized that's our first time going through synthetic division, and it kind of came out of, I wasn't really ready to get into that, but because I'm getting old and my eyes don't work and my glasses fogged up, I saw a 6 instead of a 0. So, oh well. All right, we good? We'll do another one of these in a minute. Now that we're here, we may as well get our hands dirty with it. Let's go back to the problem where we paused. Okay, we paused here. Grouping doesn't work, right? Grouping doesn't work. So now what we know is we can use synthetic, trisynthetic. By the way, synthetic doesn't always work. Okay, but it's still more powerful than grouping because we factored just now, right? Grouping failed and the synthetic worked. Synthetic, and when we do that dot, 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 we're not showing the work because we just did it all. We know that it turns into x minus 3 squared times x plus 4 equals 0. Remember, we were trying to find the x intercepts, right? Back up here. So I need to come back way up here to the top. This is negative x squared, then x minus 3 squared, then times x plus 4 equals 0. So to recap, we had this original polynomial. We knew the left side went up, right side went down. We looked at it, we said, let's pull a GCF. We pulled out negative x squared. We saw this 4 terms in here. We tried grouping, it didn't work. Synthetic division did work. We got this in yellow to turn out to be this, but we still had that negative x squared out from the very beginning. And now we can set each of these equal to 0 and find their multiplicities. So I'm going to do that on the next page. Are there any questions up to this point? Are you dizzy yet? Are you okay? What are these 3 solutions? Can you all tell me just without even doing the work? Can you just tell me what those 3 answers are? 0, 3, and negative 4. 0, 3, negative 4, right? The only way to get 0 here is by plugging 0 in, squaring it, making it negative. Is 0 negative or positive? It's neither. Is 0 even or odd? Even. Okay. All right, so here, just set that equals 0, you get 3, set that equals 0, you get 4. Now, while we kind of are sitting here looking at it, when we do step 3 with the multiplicities, can you tell me right now what's going to happen at each of these, whether or not we bounce or cross? So how about at 0? Bounce, because the power on that factor is 2, right? So now I'm looking at the powers, 2, 2, and a 1. This being even means down here at this, we're going to bounce. I'm going to put B for bounce. Is that okay? And then this one, I'm also going to bounce. And then this one right here, because it's a power of 1, I'm going to cross. And that's it. I should be able to draw it. Put my x intercepts. 0, 3, negative 4. I remember, no, I don't remember. The left side went up, right? And right side went down. So I know my left side goes up and my right side goes down. I know this must be a smooth, continuous curve. I know I've got to cross at negative 4. So that means when I'm drawing this, right, Amanda, when I'm drawing this from left to right, going down, when I get to -4, I need to cross through the x-axis. And I'm going to turn back up, bounce off at 0, go back down, bounce off at 3, and then come back down. So let me draw it the way I want to draw it. I'm going to do it this way. Bounce off. I'm going to go way down and bounce off. Again, it doesn't matter how far you go down, just as long as you go down. And remember also, when you finish drawing this, it needs to be a function. So it has to pass the vertical line test, right? Like at the end of it, if it fails the vertical line test, it's no longer a function. There it is. Okay, let's do another one. This one's going to be different. Can you all tell how this is different? -3 out there, yeah. But compared to like the last few problems I've done, like how is
It's
this
the
different?
powers. The powers are different.
Yeah, I've got these powers, right? But they've got these parentheses, right? Wait a minute. Haven't I already factored it for you? Basically, I've given you the polynomial in factored form. You're welcome, right? I mean, this is a really great thing, right? Because right now I can look at this and I can say where it crosses and bounces, can't I? The thing I can't easily see is the left and right behavior. I can't see the up, down, you know, is it up, down, like what is going on, right? Because it's hard for me to see the degree in the leading coefficient. So it's kind of like we gained a lot, we lost some, but I would rather have this than the other way because we don't have to factor. Does that make sense? Everyone home?
Yes.
It's already broken down. Okay, so let's still start with step 1. I need to find the end behavior. Now, to find the end behavior, I have to figure out what the highest power of x is and the number in front of that highest power of x, which at first glance looks like it might be hard to do. But if we just think about it, just analyze this kind of critically, I think we can convince ourselves with relative ease, we can figure out what the degree in leading coefficient would be. So look at what's in yellow, this right here. That squared. If you square this, what's the highest power of x you're going to get? X squared, right? And it'll be 1x squared. Why 1x squared? Because when you FOIL that out with itself, you'll get x times x, which will be x squared, right? So from this, the highest power coming out, the highest, will be an x squared. How about out of this one? It'll be like an x cubed. And then what about out of this one? Yeah, there would be a lot of multiplying you'd have to do, right? And that would suck, but the highest thing you would get out was x to the 6th. Now you'd have a bunch of other stuff there, right? But that would be the highest power you get. And then if you had to multiply those together, then you would have some x squared term in there times some x cubed term times some x to the 6th, somewhere in the multiplying. And if you put all those powers together, it'd be x to what power? 11th. You add the powers. Right? X to the 11th is what would come out of this. Understand that? Without doing it, that's what I'm not saying all of that turns into x to 11th. I'm saying the highest power that would possibly ever come out would be x to the 11th power. Now, this -3 would just follow along and be out here eventually in front. And so from that, I can find the degree in the leading coefficient. The degree here would be 11. and the leading coefficient would be -3. And that means we have an odd degree negative leading coefficient. Doesn't that do the same thing the last one we just did? Up on the left, down on the right, middle, we don't know. Second step, look, the second step is going to be so clean and easy, isn't it? Well, I hope it is. Let's see. The second step is the X intercepts. So I'm going to take the function and set it equal to 0. Here it is. And I'm so pumped about this. I'm so excited because it's not going to require any work from me. Right? I set each of these factors equal to 0. Well, you know, it's already factored out. What about the -3 out front? What do I do with this? Ignore it, right? Because -3 can never be 0. So we just ignore this. If you don't like that, just imagine divide both sides by -3. If you do that, then it's gone on the left, and on the right, 0 divided by -3 is still 0. So that's gone. And so I can just look at these and tell you what the answers are. The first one would be 0 if x is what? -1. Then the second one if x is 4. And finally, -5. I'm going to go further. Without even writing anything else down, I'm just going to tell you bounce cross, you know, what's going to happen. I just look at the powers. Boom, boom, boom. Even, odd, even, right? So bounce, cross, bounce. Bounce, cross, bounce.
Yes.
And that's it. We're ready to crank this thing out. Draw a picture. -1, we have an x-intercept. -5, we have an x-intercept. At 4, we have an x-intercept. The left side goes up, the right side goes down. I'm bouncing both at -5 and -1, and I'm crossing through at 4. So here we go. Bounce it off here. Bounce it off here. Cross it through. There you go. What should you do if while you're doing this, you come to the end and what you're like, what if we had done this? What if we had done this and we're supposed to cross through at 4, but in the beginning when I drew, it was up, up. Something's wrong, right? That would tell you something is wrong. Don't go doing this because then you've created an x-intercept that isn't supposed to exist, right? So you can't, everything should smoothly go together if you've done everything right. Now, let's actually take a look at this graph. I'm going to graph this on the computer, all right? Let's see if I can. So it's -3. And what was it? X, don't tell me. X minus 4 cubed? No.
X plus 1.
X plus 1. X plus 1 to the, what is it?
Squared.
Squared, okay. And then, go ahead.
X minus 4 cubed.
X minus 4 cubed. What are we missing? X plus 5 to the 6th power. There we go. There's the graph. There's the computer's graph. That's the computer's graph. So if I were to ask you right now, is this function, you know, positive or negative in here? You could probably tell from that picture, I think, maybe, right? Maybe. See, we have to go really far out to see what's really happening on this graph. And if you go so far out, you start to not be able to tell what's happening. Do you see that? So even though the computer did it quickly, you know, if you zoom out too far, you really don't know shit, do you? I mean, you're just looking at this thing that looks crazy. But I can tell you real fast, I can tell you with my graph that right? I can tell you real quick right now that, you know, between, if you go to the left of -5, between -5 and -1, if you go between -1 and 4, you're above the x-axis. Your function's positive there, right? I can tell you that real quickly. I can also tell you that once you're past 4, the graph is below the x-axis. It's very easy to read that and be able to grab information off of it. I'm just trying to show you, sometimes the computer is great because it's a quick graph, but sometimes even reading a graph off of a computer can be hard. All right, how y'all feeling about this? Huh? So let me bring up those the problems that I'd like for you to look at. Where is it? Okay, this is a set of problems. Oh, that didn't come out too great. Take a look at this and tell me what y'all think of this, just looking at all these problems. Does this look easy or does this look hard to you? They're all factored, right? This is basically a bunch of polynomials that are already factored. So you basically just do what we just did, right? I think these, for the most part, would be pretty straightforward. How about number 14? Let's look at number 14, because that's a little bit different. Just slightly. Okay, I didn't do anything. It was weird. So for this one here, let's figure out what the degree is in the leading coefficient. So if you were to look at this one right here, this one here, this one here, obviously the highest power of x that would come out of here would be x itself, right? Because it's just x plus 1. So I should get an x here. Here I've got plus x here, so I should get an x here. But what about this one? What am I going to get out of this? A negative x, because it's 3 minus x. So we get negative x here. So if I were to multiply all three of these together, what would I have? Negative x cubed. See, this negative matters. That means our left side will go up and our right side will go down because we have odd power with the negative in front. I'll show you another one just to make sure you're catching on to this. Where is it here? How about this this one right here? Hard to read it, but so this would give you an x, right? This would give you a negative x, and then this one would give you a negative x again, right? And so if you put those together, you get positive x cubed. And so the left side should go down, the right side should go up. Make sense? What about number 19? Yeah, the tricky part about this one is they didn't give it to you completely factored. X squared minus 4 can go down to be x plus 2x minus 2. But just looking at it right now in terms of the degree, that's a 5x. This is like an x squared. This is like an x. So if you multiply all these together, you should get 5x to the 4th, which means both sides would go up. So what I'd like for you to do And I will send you these problems later. What I'll do is all the notes I wrote down today, I will include this and send it to you as a file. I'd like for you to, let's just say, try the odds out of here. And if you can do the odds and you want more practice, try the evens, you know? These should be quick because once you know the degree and leading coefficient, all you have to do is determine the x-intercepts and bouncing cross. That should be straightforward. The other set of problems are these. So for these, what's the big difference here? They're not factored. So you can use the leading coefficient test. You can figure out the degree and all that stuff pretty easily. It's everything else you have to do. Now, I will tell you, none of these will require synthetic division, okay? Because all of these were before synthetic division occurs in the book. So everything here should factor with either quadratic, like either using a quadratic or using, what do you call it? Grouping, okay? Using grouping. All right with that? I still have a little more time. I want to talk about still same topic, but I want to just kind of show you something. Synthetic division is kind of a new way of factoring, isn't it? It's kind of a new way of factoring. So let's go back to the good old days. Let's say I was asking you to factor this, right? I know probably can all do that mentally, right? This factors to be x minus 5, x plus 1, right? Okay, now let's act like we didn't know that. Watch this. 1 and -5, right? I'm going to make my list real quick. Take the -5. What are all the factors of -5? Well, plus or minus 1 and plus or minus 5. Those are the only numbers that go into -5. And then I take my other number 1 and make all those, which is just 1. Now I take each of these and divide by 1, so my list becomes the original list. Right? Make sense? Now, once you've gotten good at this and you know that this is a 1, then all you're really doing is looking at this number going, okay, I just need to try 1, -1, 5, and -5, right? So I'm going to just do my synthetic division real quick. I put my coefficients 1, -4, -5. And let me try 1 real fast. 1. Okay, 1, 1, -3, -3. Nope, doesn't work. Let me try -1. 1 minus 4, -5. So 1 comes down. -1, add down, -5, multiply, you get 5. Voila, look at that, 0. See? So what does that tell me? This tells me that x plus 1 is a factor. And this tells me that x minus 5 is the other factor. And I've essentially done the same thing, haven't I? So you can actually use this synthetic division to factor the way you've done in the past. So if you've ever had trouble with factoring, this is kind of a, I wouldn't say it's kind of a shortcut. All right. Let me bring those problems back up. Let's do this. Let's do number 38. This will be for you to do right now. When you got it graphed, you're free to go. You have 15 minutes. Again, I will email you. Do not do the homework online on Pearson, right? On the web thing. I will email you the problems to do, and I'll tell you which ones to do, all right? So please try and sketch this. I'll put that back up there in a minute. I was gonna go grab the steps. That's all right.
Sir, can I see the problem real quick? I got plus 4x cubed. Right. All right, I got it. Thank you.
Yeah, sorry about that. My screen, I'm having some technical issues over here on our end. Keeps flashing on us. So let me see. Okay, you pull negative x squared out. Plus x squared minus 4 plus 2 minus 2. So you only get one bounce. That looks good. Okay, good to go. Chris, did you see what it was? Yeah, okay. How are you doing here? Having any issues? So on your grouping, how did you do that stuff? Squared. I think you missed the x squared minus 4. Right here, right here. Right. So that when you, yeah, you put x right there, right there. And then that breaks down further to the x plus 2x minus 2. See that? So that splits into 2 more. You're going to have another, there's another X intercept you're missing there. Yeah, that looks, I think that looks good. Yeah. Yep, that looks good. Yep, in order for grouping to work, they have to have the same. Yep. Yeah. Okay. Okay. How are y'all doing at home? Anyone have any questions?
Okay, so far I have 3 X intercepts. I have 0, -5, and 5.
Okay, so did you pulled out, what did you pull out of everything?
I pulled out a negative X 4.
Negative x squared?
Or yeah, I'm sorry, yeah, negative
Okay.
X squared.
And then that leaves you with a positive x cubed, a minus 5x squared, a minus 4x, and a plus 20. Do you have that?
No,
You're good to go. Yep, yep. You too. Carissa, you got it? Okay. So when you multiply through, what you have to do is figure out what do you multiply negative x squared by to get negative x to the 5th, right? So you need x cubed here. So when you multiply these two, you add the exponent and you get x to the 5th. Does that make sense?
yes, sir.
Okay, and then the next time you need a -5 because you'll do a negative times a negative, that'll give you positive 5, and then you'll add the 2 and the 2 together to get 4. X to the 4th.
Okay, yes,
And then you need a -4 here, so that when you multiply by negative, you get positive 4. And then x squared needs to become x cubed, so you need an x there.
yes. And
And then
then
the-
we're taking out the X squared from the 20.
Yes, exactly. Negative x squared from the 20, from the negative 20x squared. So that all makes sense?
Yes, sir.
Okay. Now what's in the parentheses is 4 terms. So I'm going to try that with grouping. I'll do it right here. Just check your email. I'll send the homework through email. Okay. Yeah, I think because I didn't know who was going to be here. And so just you can send it. I think I did send you the link, right? Okay.
Sir, can you check mine real quick?
Check your what?
The work. Oof.
Yeah, that looks good. Yep. Very good.
All right. I'll see you next week then.
Okay, Juan, you take care.
You too.
Have a good weekend. All right, so here we have 4 terms, so I'm going to just kind of slash it right here. And then what can we pull out of both of these?
X squared.
X squared, okay. Now what will be left if we pull x squared?
X -5.
Good. Okay, now on the next one, we need to be able to pull something out and have x -5 in parentheses again, if this is going to work. So what would you have to pull out in order to get back this?
-4.
-4. Okay, good. Now at this point, once you're here, the next step of grouping is to write what's in parentheses. And then next to it in parentheses, you're going to put the 2 things you pulled out. So x
Okay,
squared
yes,
minus
that-
4.
I missed that part right there.
That step, okay. So now we're here. And you hopefully recognize x squared minus 4 as x plus 2x minus 2. Difference of squares?
Yes, sir.
Okay, so that's it. That we have factored the part in blue here, which is the part in yellow here. So when we go back up here, we have negative x squared. We have x minus 5. We have x plus 2. We have x minus 2 equals 0. Let me move this over.
Okay, so I think we have 0, 5, -2, and 2.
Okay, and do we bounce or cross at these?
Now those, okay, so the bounce and cross, can I get the rules again for
Mhm.
bounce?
Yeah, you look at the powers on your factors. So what I mean is this 2 right here, right? That's a 2. This is a 1, this is a 1, and this is a 1, right? Those are the powers on the factors. If the power is even, then that x-intercept you will bounce at.
Okay,
If the power is odd, which the rest of these are odd, right?
yes, sir.
We're going to cross at all of those. So when we go to graph, I put all my x-intercepts down first, which are 0, 2, -2, and 5. Now, I didn't talk about the first step because you didn't, no one asked about it, but I'm assuming you're okay with that the left side goes up and the right side goes down?
Yes, sir.
Okay, so my left side must go up, my right side must go down. And I'm crossing through everywhere except 0. At 0, I'm going to bounce, okay?
Okay,
So here I go. I'm going to draw. I'm going to get to here. I'm going to cross through the x-axis, come back up, bounce off at 0, come back down, go back up, cross through. Now I've got to get back to that 5. So I turn, come back through, cross through, and then connect.
okay,
That's what we're looking for.
okay. Yes, I had forgotten to add the ones that weren't in parentheses into its own.
Over here, right there?
Yes, yes,
Yeah.
sir.
Okay. All right. Are there any other questions?
Yes, I have one.
Yes.
So what is the rules for grouping? Like, what do we need exactly in order to group things?
Okay, so when it comes to grouping, you split everything up. So you have 2 terms here, 2 terms here, right? You pull a GCF out of each one. And what you need in order for grouping to work is that once you've pulled a GCF, this and this must match. They must be the same.
Oh,
And if they're the same, then all you do is write it down. And then whatever you had pulled out, whatever you had pulled out, you write those in parentheses together.
okay, I get it. And if it's impossible for that to work, you just do like synthetic or something else.
Yeah, if it doesn't work like the problem I gave you earlier, or was it here? Yeah, here, what happened was we took this, we split it, we pulled out an x squared, which left us x minus 2. And then we were saying, okay, that means this would have to be x minus 2, but there's no number I could have put here that distributes back through and gives you this. Because you would have to have -15 here to get -15x, right?
Yes.
But if you do -15 times -2, you would have got positive 30, not 36. So it's not going to work.
Okay. Thank you so much.
Yeah, no problem. Anyone else?
I actually, I don't really have any questions pertaining to this anymore. I want some more towards the quiz.
Okay.
I know I haven't turned it in yet, but I was just almost completely lost on it.
Okay.
If I can just get a little bit of direction on what because I noticed the quadratic wasn't factoring.
Let me see. I'm trying to remember which one it was. Oh, yeah, yeah. Trying to find it.
Me too. I'm gonna bring it up on my binder.
Where the heck is it? This was last class, right?
Yes, sir.
Where is it? Should be the next page. No. Oh, this is it right here.
Yes. Okay, so on the very first one, hold on, baby. Here, you can play on it. Okay, on the first one, I noticed on the quadratic, I couldn't tell. Okay, so I started doing the quadratic formula,
Uh-huh.
which is the ax squared plus bx plus c equals 0, and then I turned that into it was the negative b plus or minus
Yes,
the root square, and then I ended up with the square root of 3,472, but I didn't know what to do with that afterwards.
Just put that into your calculator and get a decimal answer.
Decimal answer. Okay.
Yeah, this is not going to have pretty numbers to it. It's going to be decimals.
Okay. And then so after I get my decimal, am I clear on the part A?
No, because wait. Part A wants you to find the quadratic function that gives you the height of the rock. So the original problem was this, right?
Yes, sir.
Okay, so the first question was, how do you turn this word problem into a quadratic function? We did that in class.
Okay.
So that's the answer.
Okay. I didn't
Okay.
know if you wanted me to solve that or not.
Well, I do, but that's part D. Part D
Okay.
is saying, when does it hit the ground? So you're setting it equal to 0. And that's when you're going to use a quadratic formula and you're going to get your solutions.
Okay. So that's okay. So that one will be so my decimal number will be part D.
D, yes. Uh-huh.
Yes. Okay, perfect. Okay. Now on B and C, do you want me to graph it?
Nope. You just have to give me a number. These two are going to give you numbers.
Okay. Can you give me a little bit of direction on how to maybe come up with those two numbers?
Okay, so if I gave you a parabola, just a general parabola, forget the word problem here. If I ask you to find the vertex, could you find the vertex of a parabola?
Yes.
Okay, you have to find out what h is, right? And then what k
Yes.
is.
Okay.
H is a formula, right? There's a
Yes.
formula for h, negative b divided by 2a.
Okay, yes, I did see that one. Okay, yes.
Okay, so
So,
to
and that
find-
was for H, I'm sorry.
yeah, that's for h. H is
Okay.
negative b over 2a.
Perfect.
So that's
Okay.
what part C is asking, is for you to find out when it reaches its maximum height. So you have to calculate what h is.
Okay.
Then once you have h, you can get k by taking h and plugging it into the function.
Okay, perfect. And K would be basically my time, right?
Your time would be C. That would be h.
Okay.
Your k would be how high the ball or the rock actually went. So it would be like in feet.
Okay. Okay. And is there a different formula for K?
Yes. K is what you get when you have to find the answer h first.
Yes.
Take that answer, plug it into the function, and that gives you k.
Perfect. Okay. And the function K is going to be my height.
K will be the height. Yes.
Okay,
Mhm.
perfect. Okay, all right. Thank you, Professor. I'm so
Okay.
sorry. I'm just a little
Yeah.
bit behind on the math, so that a lot of it kind of I just needed a little direction to plug the numbers in.
No problem. No problem. If you need another day or so on that, that's fine with me.
Okay, I should be able to submit it tonight, no problem. Thank you
Okay.
so very much. Have a
Okay.
wonderful day.